My dear student, I am going to teach you the third part of lesson number 2 of ninth class, that is factorization of the polynomial. Factorization of the polynomial can be done with the help of the factor theorem. What is the definition of factor theorem? This is a factor theorem. If Px is any polynomial of degree greater than 1, this is the condition. If Px is any polynomial of degree greater than equal to 1 and A is any real number, then first condition, x minus A is a factor of Px if Pa is equal to 0. Second condition, Pa is equal to 0 if x minus A is a factor of Px. My dear students, with the help of this factor theorem, we can find out the factors of any polynomial. But one thing I want to tell you, yesterday as I have told you that the remainder theorem is a very important for getting the factors, because with the help of remainder theorem we can check whether the second polynomial is a factor of first or not. So now I am, with the help of example, I want to make it clear that how the remainder theorem is very essential in getting the factor of a polynomial. Examine whether, example first, examine whether x plus 2 is a factor of x cube plus 3x square plus 5x plus 6. This is a question. We have to check this x plus 2 is a factor of x cube plus 3x square plus 5x plus 6. There are two polynomials. Write down px x cube plus 3x square plus 5x plus 6, and other polynomial qx is equal to x plus 2. This is a px polynomial, this is a qx polynomial. We have to check qx is a factor of px is or not. Now find out the value of x. I am going to use the remainder theorem. Yesterday I have told you about the remainder theorem. Remainder theorem is a very essential for checking the factors of one polynomial to the other. Now find out the value of x. X is equal to minus 2. And by putting this value in px, in place of x, p minus 2 is equal to minus 2 cube plus 3 into minus 2 square plus 5 into minus 2 plus 6 minus 8 plus 3 into 4 plus 5 minus 10 plus 6 minus 8 minus 10 plus 12 plus 6 minus 18 plus 18 is equal to 0. by putting the value of x or by putting the value of this variable from the second polynomial in first in place of x, this value makes this polynomial 0. So this is a factor of this polynomial. So therefore this implies that x plus 2 is a factor of px. This is the method of checking the factor, whether it is a factor or not. And one thing I want to tell you more, that minus 2 by remainder theorem, minus 2 is the 0 of this polynomial, because this value makes this polynomial 0. So this is the 0 of this polynomial. So with the help of remainder theorem, we can check qx is a polynomial of px or not. So I am taking second example. With the help of remainder theorem, we can find out any unknown variable in the polynomial. Example 2. In example 2, find the value of k. Example 2, find the value of k. Find the value of k if x minus 1 is a factor of polynomial 4x cube plus 3x square minus 4x plus k. Here also there are two polynomials. This polynomial px 4x cube plus 3x square minus 4x plus k, and second polynomial qx is equal to x minus 1. From the statement, write down these two polynomials, find out the value of variable from the qx, x is equal to 1, by putting this value in the px. P1 is equal to 4 into 1 cube plus 3 into 1 square minus 4 into 1 plus k. P1 is equal to 4 plus 3 minus 4 plus k is equal to 4 cancel with 4, 3 plus k. This is P1. Now here by remainder theorem, this factor is this polynomial is a factor of this. Yani qx is a factor of px. If this is a factor of this, then the value of this variable makes this polynomial 0. So this is the condition. This implies P1 is equal to 0 because qx is a factor of px. So therefore 3 plus k is equal to 0. K is equal to minus 3. This is the value of k. So by the help of the remainder theorem, we can find out the value of any unknown variable given in the px. So next example. Next example. Factorization. Now come to the factor by factor theorem. Factorize. Factorize 6x square plus 17x plus 5 by using the factor theorem, or by we have to factorize this polynomial, and we are using here splitting method. By splitting method, by splitting method, by splitting method, we have two numbers. We can have two numbers, p and q. P and q, where p plus q is equal to 17. PQ is equal to 6 into 5 is equal to 30. P plus Q is equal to, you can say P plus Q is equal to B, and PQ is equal to A into C. If you compare this polynomial with AX square plus BX plus C, the values of A is equal to 6, B is equal to 17, and C is equal to 5. By putting these value here, you will get P plus Q is equal to 17, PQ is equal to 30. Now, we have to check the pairs of 30. All pairs of 30 are 1, 30, 2, 15, and 3, 10, and 5, 6. These are the factors, all factors of 30. All factors of 30. 1 into 30, 30. 2 into 15, 30. 3 into 10, 30. 5 into 6, also 30. But we have to select one pair from here. Listen to me very carefully. You have four pair of factors. You have to select one pair whose product is 30 and sum is 17. This is the pair. If you add these two, you will get 17. If you multiply these two, you will get 30. This is the right pair. With the help of this pair, you can find out the factor of this polynomial. 6x square plus 17x plus 5. 6x square, by, as I have said, that by splitting the method, split this term, 15x, 2x plus 5, taking 2 at a time. 3x is common, 2x plus 5. From here 1 is common, 2x plus 5. Taking out 2x plus 5 as a common, and 3x plus 1. These are two factors. These are the two factors of this polynomial. So this is a splitting method in which you have to split the middle term. You have to split the middle term. And this is a very simple method. You can check this method with the help of more examples. Do yourself. Now again, now I am taking one more question. Factorize. This is a very interesting topic. find out the factor of a polynomial, you will get a you will get a example 3. Factorize y square minus 5y plus 6 by using factor theorem. We have to factorize this polynomial by using factor theorem, because today we are using factor theorem, and we are taking the help of remainder theorem also. So this is a polynomial, and this is a quadratic polynomial. And one thing I want to tell you here, quadratic polynomial can have 2 factors. Cubic polynomial can have 3 factors. And now we have to assume 2 factors here, x plus a and x plus b. Let there are 2 factors, x plus a and x plus b. Now take this 6, take this 6 and factor of 6. Factors of 6 are 1, 2, 3. These are 3 factors of 6. And we have to check one by one in Px. First, put the value of x 1, P1, 1 square minus 5 into y. We have to put the value of 1 in a Py, because the polynomial in y, here variable is y, so we have to take Py. If variable is x, we have to take Px. If variable is t, you have to take Pt. Mind it. 1 plus 6, 1 minus 5 plus 6, 7 minus 5 is equal to 2. Hence, this implies that this is not a factor of Py. X minus 1 is not a factor of Py, because we have taken 1 as a value of y. So y minus 1, here I am making mistake, because polynomial in y minus 1 is not a factor of Py. So check another factor. Py is equal to y square minus 5y plus 6. Check this second, 2. P2 is equal to 2 raised to the power 4, 2 raised to the power 2 minus 5 into 2 plus 6. 4 minus 10 plus 6. 10 minus 10 is equal to 6. So therefore y minus 2 is a factor. Y minus 2 is a factor. Here x minus y minus 1 is not a factor. Not a factor. Leave it. Now third, Py is equal to y square minus 5y plus 6. Here put the value 3 in place of y. 3 square minus 5 into 3 plus 6. P3 is equal to 9 minus 15 plus 6. P3 is equal to 15 minus 15. P3 is equal to 0. This implies y minus 3 is a factor of Py. And a y minus 3 is a factor of Py. Write down this. Hence, these two are factors of this polynomial, y minus 2 and y minus 3. So therefore, factor of y square minus 5y plus 6 is equal to x minus y minus 2 and y minus 3. These are two factors of this polynomial. This was the another method. First was the splitting method, and this is a method of checking one by one all the factors of 6. So now I am taking one more example. Px is equal to x cube, x square minus x plus x minus 2, where x minus 1 is another polynomial. This is the first polynomial and this is the second polynomial. We have to check is qx is a is qx is a factor of px. Find out the value of x from qx. X is equal to 1. By putting this value in px in place of x, p1 is equal to 1 square plus 1 minus 2. 1 plus 1 minus 2. 2 minus 2 is equal to 0. Hence, p1 is equal to 0. This means this value of variable x makes this polynomial 0. Hence, this x minus 1 is a factor of this polynomial. And 1 is the 0 of this polynomial. So by remainder theorem, we can check each and every factor, whether is it a factor or not. So in part third, factorization of polynomials is a very important topic. Factorization of polynomial is a very important topic because you will get one question in the examination of factor. You will be given by a polynomial, any polynomial. You have to make the factor of that polynomial. And there is no condition by which method you will do. You can do by with any method. So learn all the method and apply in the examination one of the method. But the factor should be correct. So please, I want to make a request in the last. Subscribe. It is my request to you. Subscribe the channel. I shall be very thankful to you. Thank you.